Speaking of girl math, in the discourse over the supposed shape or true shape of planet Earth, I have never heard a single person bring up, well, what about celestial navigation? And luckily for you, I was a merchant marine, and my college degree, in simplified terms, is in ship driving. And one of the requirements was learning celestial navigation. The Kelsey lore runs really deep. A lot of this information isn't on the internet, but I'm going to provide very simple overview. There's a lot to it, so bear with me. Celestial navigation can be traced back to ancient Egypt. The sextant, this device right here, has been in some way implemented or used since the mid-1700s. It's used to observe celestial bodies. And you see this arm right here? Basically, you take a body, some form of celestial body, sun, moon, stars, etc. You take the sight and you move that arm to bring it down to the horizon, and you annotate to get the altitude of the body. And the altitude is one of the many items needed to build an estimated position where your ship could be. And this right here is the overarching calculation to get us online. Whenever you shoot a body, because that's what we call it, you have to get the time, LMT, local mean time, and you apply your zone description. And the zone description is where you're located at the time that you get your local mean time. So in relation to the Greenwich meridian or the 0 degree of longitude, so you get the time at Greenwich, England, for annotating your site. HS is the apparent altitude. It's the numbers you get from the bottom of the arm of when the site, when the body is on the horizon. Then you have to apply corrections from the sextant, any sort of like deviations, so you get the observed altitude of the site. The next part is getting the local hour angle, which is the importance as to why you calculate Greenwich Mean Time of the time you took your shot. So you take the time of when the observation was made, go into the nautical almanac, find the Greenwich hour angle of the site, you apply your assumed longitude to get the local hour angle. This diagram breaks down local hour angle very well. The angular distance measured at the center of the Earth or the poles between the meridian, which is you, the person, and the meridian of the celestial body. Then you have to find the declination. It's the angular distance from the celestial equator to the body. And then after calculating the local hour angle, the declination, and having the assumed latitude, you enter into another publication called 229 to get Z or ZN, which is dependent on the angular degree of the local hour angle. This is a diagram just for example, but after getting like at least 3 different sun lines over time, you can plot a running fix, which will enable you to have an estimated position as to where the ship could be. It involves plotting all 3 of your azimuths and then advancing other lines to coordinate with the dead reckoning positions. And the distance between the dead reckoning positions, you kind of transcribe that over to the distance between zeniths, and you can take your earliest zeniths and move it. So at the same time as your, like, let's say you take 3 fixes of your 3rd fix, you can advance your 2 previous fixes. So all at the 3rd time, you can have the idea of the estimated position. So yeah, that's just one example of how celestial navigation can work. I'll give you some time to process all of that, and then I have to do another part explaining the formulation on the perceived perception of Earth itself.